Hello my dear students, this is Akash HD and welcome to the ASD Physics classes students. I hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter rotational motion and very important question from the topic moment of inertia. Even we will use here parallel axis theorem and the basic formula and all that, all the things we are going to learn students. Okay, so let's start the video and let's see the question. Two identical spheres, each of mass 2 kg and radius 50 centimeter are fixed at the ends of a light rod so that the separation between the center is how much here? 150 centimeters. So here, this is one sphere by default solid and this is also solid. Okay, radius how much here? 50 centimeter, 50 centimeter. And in the question what they have given? The separation between their centers is how much here? 50 centimeter. Okay, now then moment of inertia of the system about an axis very important, see, about an axis perpendicular to the rod and passing through its middle point is how much is given here? X by 20. So in the question what they are asking, the value of x. Okay, so students, first let's see here, each mass how much is given here? 2 kg. So we'll write here, students, this mass m is how much here? 2 kg. After that, the radius of each ball how much is given here? R equal to 50 centimeter. Okay, here you can see the unit is the SI unit, so here we will convert into SI unit. Okay, so you know 1 centimeter means 1 by 100 meters, so we can write here 50 by 100 meter, or we can tell 1 by 2 meter. Okay, now to solve this question, first we will solve moment of inertia for this sphere about this axis, then moment of inertia of the second sphere about this axis, then we will add them. Okay, so let's take students, this is the body 1 and this is the body 2. Okay, and let's take, I have taken here, this is I. So students, if I talk about this sphere 1, so what will happen that here, let's take here, this is the axis passing through the center of mass of the sphere. Okay, and about this axis, moment of inertia how much is there? ICM, center of mass, because this is the center of mass. Okay, and now you know value of ICM how much is there? 2 by 5 mr square for the solid sphere. Okay, now if I want to know the moment of inertia of this sphere about this axis, you can see students, both these axes are parallel to each other. That means parallel axis theorem is valid and one of the axis is passing through the center of mass definitely. Okay, so you can see very well this length how much is given here? This length 150 by 2, that means how much is 75 centimeter. How much is 75 centimeter? Remember that this 75 centimeter we have to convert into the meter depending upon this question condition. Okay, so what will happen that here students, see, moment of inertia of the first body, okay, about this axis. Now so we can write here students here this I1 now I1 about this axis. So what this will become here? First ICM, I am applying the parallel axis theorem, ICM plus m into d square. What is d? D is the distance between two axes. Okay, so what will happen that here, this ICM value you know very well, 2 by 5 mr square. Okay, plus again mass m into d value how much is given here? See here students, 75 centimeter. 75 centimeter means how many meters? See here please, 75 centimeter means again 75 by 100 meter. So 75 by 100 means just cancel by the 3. So it will come here the 3 by 4 whole square. Okay, this thing is it. So first let's calculate this thing, then it is the identical for this also, we will make it at twice. Okay, I hope so this is the very clear. Okay, so see here. So as we have got here I1 value, even I remember here, this I1 value is coming, how much is there? 2 by 5 mr square plus m into 75 by 100 means how much here? 3 by 4 square. Is it? Let's simplify this for single side. Okay, so what will become here? This will students, see, 2 by 5 into mass how much is given here? 2. Let's check even one time. No, let's check here one time. How much is given here? 2. Okay, and the radius 1 by 2 is there. Okay, so here students 1 by 2 square plus mass 2 and here 9 by 16. Is it? 9 by 16. Now what will happen that here you can see very well, this 2 into 2 4 and here 1 by 4, that will cancel out. That means we can write here, see, 1 by 5 plus here 2 8 is 16. That means it will come here the 9 by 8. Going correct? 1 by 5 plus 9 by 8. Now if I take here the LCM of 8 and 5, how much is there? 40. Okay, Now 5 8 is 40, so 8 plus, and here how much here? 8 5 is 40, so 5 into 9 students here, 5 into 9, 5 9 is 45, 5 9 is 45. So what it is coming here? It is coming here the 53 by 40 kilogram meter square for the system 1. System 1, this one here. Okay, similarly, if I write for the system 2, same identical situation is there. Here also you know very well, this distance is 75 centimeter and this is the radius 50 centimeter, correct now? So moment of inertia of this sphere about this axis, how much? I2. Okay, again I'm writing here, see, due to this I1, moment of inertia is how much is there? I1. And due to this I2, moment of inertia is how much here? I2. Okay. And what is the value of I2 students? The I2 value is same now, because identical situation. Now what will happen at here? What is the total moment of inertia? So by principle of superposition, we can write the total moment of inertia is given by I1 plus I2. What is this? I1 plus I2. Okay. So what is this? 53 by 40. This one 53 by 40 plus 53 by 40. So what this will become here? 53 by 20, is it? See here, very basic, 53 by 20 kilogram meter square. Okay, and this thing we have to compare with which one? This thing we have to compare with the x by 20 kilogram meter square. Okay, then what is the value of the x? The value of x, students, 53. Kindly see very well, the value of x how much here? 53. Okay, so students, here the value of x here we have put here the 53. Okay students, so I hope so this question you have understood very well. Keep studying, keep growing.